All right, this is Honors Algebra 2 Pre-Calculus. We are doing 6.4 in Algebra 2. This is our second video. We are solving log equations. So solving logarithmic equations depends on the look of the original equation. So we're going to walk through three of the most likely options. And of course, there can be trick questions that don't look like one of these at first glance, but usually you can clean it up to match one of these three options. So a thing to keep in mind is that as you move forward in math, and probably also life, like everything's like this, right? You have to assess a situation and then determine how to move forward from there. So when you look at an equation that has logs or something that involves factoring, or whether you're just looking at the best way to handle something at your job, you have to take a step back, look at the situation, and determine the best method to move forward. And sometimes you're going to choose wrong and have to retrace your steps and start again. And that's okay. Right? All right, so option one, both the left-hand side and right-hand side have one single logarithm. So that's something that we're going to be talking about in this video, 6.4. Here, you can apply the one-to-one property, which basically means you can just ignore the logs altogether. If log base b of x equals log base b of y, the stuff inside the logs, x equals y, right? So option two, multiple logs on one or both sides. So in this situation, you can combine the logarithms on either side, like the ones on the right-hand side or the left-hand side as needed, to make a single log on each side. Then you have log stuff, like log of stuff equals log of stuff, and you can say that the two things are equal, which is option one again. When it gets a little bit more complicated, we're going to have some terms that don't have a log at all, and that'll be our third option. We're going to address that when we get to 6.6. Regardless, in all cases, maybe that's 6.7. Anyway, I think it's either 6.6 or 6.7. Maybe it's 7. Hard to know. Okay. So in all cases, because logs have a domain restriction, you have to plug in your answers back into the original equation to check. If the answer doesn't work in the original, then it is called an extraneous answer, and you need to mark it as such. So we are going to get some extraneous answers, meaning we're going to get some answers that look right when we're solving but don't turn out to work. So we need to be aware of that. Okay. So let's go ahead and solve. So this is that first option where I have log base 2 of stuff equals log base 2 of other stuff. So I can apply that one-to-one property and say that this means 7x equals x squared plus 12, right? Because again, this is that log base b of x equals log base b of y, so x equals y, right? Now I'm just going to solve the way I'd solve anything. I'm going to move the 7x over because I'm going to have to factor this. I see that there are multiple powers of the variable. I'm going to get an x minus 3 times an x minus 4. So the two answers I'm going to get are x equals 3, because that's when x minus 3 would be 0, and x equals 4. So these are my two answers. I now need to check them in the original logs, right? So the way I usually do this, right, is I just go ahead and check, I check each one of them in the original equation, right? So I'm going to get log base 2 of 7 times 3, which would be 21. The question is it equal to the log base 2 of 9 plus 12? Hey, look, that's a 21. Yep, we're all good. Okay, so I'm checking for two things. Is it true, right? And is it in the domain? Because that's the other issue, right? I can't have a negative inside a log. This is a positive 21. This is a positive 21. I'm all good. So that one works. So x equals 3 is an answer, and x equals 4 when I check it is going to give me the log base 2 of 28. We're going to see if that's equal to the log base 2 of 16 plus 12. Hey, look, that's also a 28. Yes, it is both true and gives us a value in the domain, so both answers work. So my answers are x equals 3 and x equals 4. There are no extraneous answers. Sometimes an answer will be extraneous. All right. So go ahead and try P4. You are welcome to pause me if you want, but again, this is a one-to-one situation. This stuff has to equal this stuff. So 3x squared minus 1 equals 2x. 3x squared minus 2x minus 1 is 0. All right, I know that when I factor, I'm going to have a 3x and an x, and I'm going to have a 1 and a 1 with opposite signs. That pretty quickly narrows down what's happening, right? So I know that both of the back seats are 1. I know that I want to net a negative 2, so I need this 3 to be the negative and the regular x to be the positive. So either 3x plus 1 is 0, which gives me x is negative 1/3, right? Or x minus 1 is 0, which gives me x is 1. So I now have to check both of those answers. And remember, I'm not someone who usually tells you have to check an answer just to check an answer. But here you do because of logarithms. You're not checking to see if your math is right. You're checking because logs have issues when you solve them that often answers become extraneous. So I'm going to go ahead and see what happens when I plug in the negative 1/3. So honestly, I'm not even going to bother on this side. I'm not even going to bother because I notice that on this side when I plug in, I get that this is a negative 2/3 and it's not okay. Nope. Not okay to have a negative inside a log. So I'm just going to go ahead and mark this as extraneous. You could plug in this side, but my point here is that once it doesn't work, it just doesn't work for everybody. So extraneous. There we go. Okay, so that one's extraneous, right? And you could check it. If you did check it, when you plug in the 1/3 and square it, it doesn't matter, it's negative because it's squared, you're going to get 1/3 minus 1, which is a negative 2/3 for the record. It is a true statement, negative 2/3 on the inside, negative 2/3 here, but you can't have a negative inside a log. Not okay. And then I'm going to go ahead and try 1, right? So I'm going to get log base 5 of, when I plug 1 in, I get 3 minus 1. Is that equal to the log base 5 of 2? Yes, it is. This is a 2. This is also a 2. So this is the answer. So my answer is just x equals 1. All right, moving on. Okay, so now here we have multiple logarithms, right? So here we have multiple logarithms. Before we can do the one-to-one property, I need to combine these, okay? So I need to combine these into one logarithm, and then I can use the one-to-one property. So I'm going to do that by bringing that 2 up first. So I'm going to get that this is the log base a of x squared plus the log base a of 2. And then I'm going to recognize that that combines to multiplication. Since we generally put the 2 in the front of the x squared, we're going to do that. Now I can apply my one-to-one property, right? So I'm going to get that now that it's log base a of stuff equals log base a of stuff, the stuff has to be equal. So 2x squared equals 5x plus 3. Move everybody to one side, and I really prefer having a positive leading coefficient. Oh, sorry, my bad, that's a negative 3. I really prefer having a positive leading coefficient, so I'm going to move everybody to the 2x squared side. I know this has to be a 2x and an x. I know this has to be a 1 and a 3, but that they have to have opposite signs, right? That's what the negative tells me. One of the things you might notice here is I'm really not spending a lot of time on factoring with you because, as I mentioned, when we learn factoring, it's going to be a skill that you just have to know how to do. So if you're still feeling at all weak on factoring, please, please, please spend some time going back over my factoring videos and go on the internet and find factoring worksheets if you need to, or email me and ask for factoring worksheets, but you need to be able to factor. So I get these two answers, and now I'm going to check them. Here's the nice thing. In this problem, since there is an inside that's just an x, I can't plug in a negative. Like, I know that I can't plug in 0 or negative, right? I can't do it. There's just an x by itself. So this is already extraneous. I don't even have to do a whole lot of work there. That one's already extraneous. Not give myself enough room to write the word extraneous. Okay, so then we're just going to check this one, right? We're going to check the other one. We're going to check this guy. So when I check, right, I'm going to get 2 log base a of 3 plus log base a of 2. And the question is that the same as the log base a of, when I plug in a 3, right, I get 15 plus 3, which is an 18. So the question is, does that come out to be 18? Well, this is a log base a of 9 plus a log base a of 2. Sure enough, when I combine these two together in multiplication, they're also an 18. So, yep, that's an 18, that's an 18. So my answer is just 3. Now, you might say, okay, but Hogan, why couldn't I plug back into like this equation that I'd already simplified? Well, here's the problem. The negative number, this negative 1/2, would have worked in here. You have to check it in the original because it is the very action of making the changes that we made to solve that gives us these false positive answers, these extraneous answers. So it's very important that you check it in the original and see that I couldn't plug in the negative 1/2 here. It doesn't matter if it worked over here because it doesn't work in this log, and if it doesn't work in any of the logs, it's not an answer. All right, let's go ahead. You try P2. Pause me if you want. So the first thing I have to do is I have to combine this, right? Now, if you can do this in one step instead of 2, if you can recognize that this becomes a squared and then it's multiplication, that's great. If you don't need as many steps, that's totally fine. Once I have that this is the log base 3 of 5x squared equal to the log base 3 of 14x plus 3, I can use that one-to-one property to say 5x squared equals 14x plus 3. Again, I really like to keep my x squared positive, so I'm going to subtract the 14x and the 3 over. I know that this is a 5x and an x, and I know the only ways to get a 3 are a 1 and a 3, but that I need opposite signs. I'm pretty sure I want a 15 and a 1. It seems really likely that I want the 5 to be multiplied by the 3. So when I do this, I say, okay, I'm pretty sure I want a 15 and a 1. I want a negative 14, so the 15 needs to come out negative and the 1 needs to come out positive. So what that means, right, is that either x is negative 1/5 or x is 3, right? Those are my two possible answers. Well, again, I'm in that lucky situation where I look here and I say, wait a second, there's an x by itself. I can't plug in a negative into a logarithm, right? Now, if there's other stuff inside the logarithm, if it's like inside the log is 3x squared minus 4x, blah, blah, blah. Then you can plug in and check if the net is negative. But here, there's only an x. The only thing I'm doing is plugging in x, which means that this is an extraneous answer. I can't plug that negative in. So that's extraneous. When we check 3, right, because we should check that the 3 works, I'm going to check it in the original. I'm going to get 2 log base 3 of 3 plus log base 3 of 5. And the question is that equal? So I'm checking the x equals 3, right? So when I check x equals 3, is that equal to the log base 3 of, when I plug a 3 in, that's a 42 plus a 2, so that's a 45. So I get that this is the log base 3 of, when I bring the squared up, 9 plus the log base 3 of 5. Sure enough, when I combine these in multiplication, this is a log base 3 of 45. Yep, same answer. So my answer is just the x equals 3. All right, cool. That's it for this video.